All right, here's a cool little trick I want to show you guys. Before we get to the trick, I'm going to start with a question that I want us to be able to solve at the end. 4 over 7 plus 5 over 6. And before we get to solving that, I want to talk about a couple things. So we'll leave that till later. Now, let's start with this other easier question over here. What about 2 plus 3? Well, I know that 2 plus 3, that's easy. That's just 5. What if I said, you know what? On this 2 plus 3, I just, for no apparent reason, I want to multiply this 3 times 1. Now, normally I'd say you can't just go adding terms to to your expression because it's going to mess things up. It's not going to make it not equal to 5 anymore. But actually, because I just multiplied by 1, well, 3 times 1, it still just becomes 3, and then 2 plus 3 is still 5. Now, if I want, I can do the same thing over here. Let's say I want to just multiply by 1 over here for the heck of it. Normally, multiplying by another term is going to change it and mess it up. But if I'm just multiplying by 1, it doesn't change anything. 2 times 1 is 2. And I can bring down a 3. 2 plus 3 still gets me 5. So the lesson learned from that is that I can multiply by 1 and it doesn't change anything. I can multiply by 1 as many times as I want and everything stays the same. That's important. So first lesson, you can always multiply by 1. That's really the lesson. You can always multiply by 1. Next thing to pay attention to is any number divided by itself is 1. So 5 divided by 5, that's 1. 7 divided by 7, that's equal to 1. X divided by x doesn't matter. Anything divided by itself is 1. Okay. So then what have I said? Tough little question over here. What have I said? 8 times 19 over 19. Now you might be tempted to make this into a fraction, 8 over 1, and then multiply across, and then you end up dividing. But I know that 19 over 19 is really just 1. So I can say this is 8 times 1. It's just 8. It didn't change anything. As long as I multiply by 1 or something that is 1, right? This doesn't look like the number 1, but really, I know that it is 1. It doesn't change anything. And so that's the same thing to say that, hey, if I go over here and I multiply this by 6 divided by 6, well, I know that 6 divided by 6 is just 1. So 1 times 2 is 2. I can bring down the 3. It still didn't change anything. Okay, now that leads us to the question that we started with. How can I solve this? To be able to solve this question, I need the bottoms of my denominators, the bottoms of my fractions, called my denominators, to be the same value. Here I've got a 7 on the bottom. Here I've got a 6 on the bottom. When you multiply fractions, you can just go straight across. When you add or subtract, my denominators must be the same. Now, to solve this, what I'm going to do is multiply by some version of 1, which I know I'm allowed to do in an expression, to change what it looks like, but since I'm multiplying by 1, it's not going to change the value. The version I'm going to use, I can find by the denominator from the opposite term. So to fix this term and make it so I can add it, I'm going to multiply by a version of 1 using this number over here. The version of 1 I'll choose is 7 over 7. I'm just multiplying by 1, so I'm allowed to do it. It's not going to change any value. Same thing over here. I've got 6. So this opposite term over here, I will multiply by 6 over 6. I'm going to rewrite this down here because I do not want to run out of space. So I now have 6 over 6, this version of 1, times 4 over 7, plus 5 over 6 times, I got it from this denominator, 7 over 7. Now, following PEMDAS, I'm going to deal with my multiplications first, and I can just multiply straight across. 6 times 4, 24. 6 times 7, 28. And then plus 5 times 7 should be 35. Yep. And 6 times 7 still gets me that, 6 times 7 isn't 28. 6 times 7 is 42. 42. And 6 times 7 here, 42. Great. Now that I've got my bottoms to be the same, I'm allowed to add them. So I can add them. You just keep that bottom the same. So I've still got over 42, but I get to add the tops. 24 plus 35 is 59. And we solved our problem. Now you might be wondering, wait, but I multiplied by a thing. I'm not allowed to multiply by anything. It changes it. But don't forget, I multiplied by 1 over here. If you want to check, throw 5 divided by 6 into a calculator, and then throw 35 divided by 42. I guarantee you will get the same answer. Same thing goes for over here. This skill is going to help us in our algebra later on.